Hey everyone! In today's video, we will see code implementation for k-means clustering algorithm from scratch using Python libraries. K-means is an unsupervised machine learning algorithm that you can use to find patterns in your data. K-means is a Centroid-based clustering. We start by deciding the number of clusters we want to find and choosing randomly the k-centroids from the dataset. Then we assign each data instance to the closest centroids. After that, we set the position of each centroid to be the mean of all the instances in the cluster. The loss function in this case is the Euclidean distances. In this notebook, we will see implementation for hard k-means, which means that each instance will be assigned to one cluster with 100% certainty, unlike soft k-means that the algorithms return a list of likelihoods that an instance belongs to a particular cluster. So after importing the relevant libraries, let's dive into the implementation of k-means clustering algorithm. In the initial function, we set k, epsilon, and max iteration parameters, and we also set empty clusters and centroids lists. And this time I'm going to start with the fit function and explain the rest of the functions as we go along. So we start by choosing randomly k instances from our data, and then we start to go over the data max iterations times. The first thing that we do in the loop is to store the previous centroids so we could check convergence later. Then we cluster the points. So let's go over the relevant function. So this function assigns each data point to a cluster by measuring the distance to each centroid. So first we create an empty list in the size of k, and then we go over each instance in the data and calculate its Euclidean distance from each centroid. Then we check which instance is the smallest and take the index and assign the instance to be in its group. So now let's go back to the fit function. So after clustering the data, we recalculate the centroids to be the mean in each group. So in this function, we go over each cluster and calculate the mean values in each group of vectors. And then we get a new centroid vector that now represents a cluster. After that, we check model convergence. So here we check the distance between the last centroid and the new one. Then we take the results and take the maximum distance in the list, and then check if the distance is smaller than epsilon. If it's true, this is our cue to stop and return the clusters that we found. If not, the loop continues. So now let's test the model with the iris dataset from sklearn. So we load the data into X and Y, and as you can see, the set contains 150 instances and 4 features. Then we can plot our data, see that I only printed 3 features. Now it's time to train our model. So we set k to be 3. I won't go into details, but basically there is a method that helps you to choose the best k. It's called the elbow method. And now after setting k, we can start training. So in clustering algorithm, there is no such thing as train and test sets. Since in real-world clustering problems, the data is not labeled and we can't measure accuracy by checking the ground truth. So instead, we will use a different method to measure the model. So this time I'm not going to split the data into train and test, and we are just going to train the model on all of our data. After training, we can plot again the data, this time with the predicted labels. And the last step is to get the model accuracy. So in unsupervised problems, we measure model's accuracy with silhouette score that checks how good we splitted the data. The range of this score is 1 minus 1, with 1 being the best score and minus 1 the worst. Value near 0 indicate overlapping clusters, and negative values generally indicate that a sample has been assigned to the wrong cluster. So in this case, the accuracy was 0.38. So yeah, that's it for this video. Thanks for watching.